so much. So yeah, as Martin said, I'm going to be talking about how ICM works. And if we have enough time, that I wish we have, we'll have a quick demo on how to send a message. This is going to be especially useful for those participating in the hackathon. This is going to be the basics, but also, as I said, how to build a cross-chain message. And from that, you can extend the functionality to build a complete cross-chain application. So first of all, by now you probably already know, but this is how Avalanche looks right now. There's a bunch of different networks, and we don't want each of these networks to be like an isolated silo. So why we need or why we care about interoperability and what we can do with that. So here are a couple of things that why we value that, but basically asset bridging, make it liquidity flow across different chains. That's the thing that we want to have, especially because it brings efficiency to the markets and also prevents fragmentation. The other thing is data portability. I mean, we are in Web3. We want to be owners of our own data. We want to own what we have, and why not being able to move it around however we want to. Next thing is protocol access anywhere. So you don't need to be in certain chain in order to access that protocol that is deployed in another chain, but you can actually access that from wherever you feel more comfortable. And the last but not least is service tunneling. This one is pretty interesting because whenever you launch your own chain, and I will just use Chainlink as an example, some services are currently deployed only on C-chain. So if you want to consume, let's say, an Oracle or a price feed or whatever data is currently stored in, well, or service that is currently deployed on C-chain, you can actually tunnel that service into your L1 without the need of Chainlink going to deploy their own oracles into your own chain. You just consume that from what it's already available on the C-chain. So let's go into interoperability basics. And for that, I want to sing with the vibes of this amazing venue, and I want you to picture that you are in some medieval towns that you want to communicate between both of them. So we have like the source chain and the destination chain, and they are communicating via messages. So basically, any message is telling the other town or the other chain something to do. So again, if we are one of these towns, imagine you are the one that are receiving the message, and this message is open the gates of the realm because the king of my town is coming visiting you, and you need to make sure that is not an enemy, okay? So you need to see that message is a proof of something that occurred in order for you to actually open the gates. So some parentheses here about why we have, why is it important to have like super fast finality when we do cross-chain interoperability? And it's because whenever we have an event, let's call it event A, and then that triggers an event B in another chain via this message that we were talking about, we need to make sure that this event A is set forever. Because if not, if this event A gets reverted, then what will happen with event B? Who tells event B, who tells the chain B, hey, you know what, that never happened. The king never went out from our town, so you know what will happen? The gates, it's already open. So that is why finality in cross-chain operations is so important, and why Avalanche plays an important role when we are not only interoperating with another chain, but also with the real world. At the end, you want to this transaction or whatever is going on chain to be settled in order to actually do some stuff in the real world or in another chain. So you have a message that is being transferred, and there is someone that relays that message and sends that message to the other town. The question is, can I trust that messenger? Can I trust that relayer? And the first option is no, so let's decentralize it. So that is one way that we can solve the problem of trusting the relayer. The other way that we can do it is you don't really need to trust the relayer. You just need to sign the message. And in order to get that message signed, you're basically securing that with a layer of confidence that that message is being non-tampered with, it's coming from who says it's coming, and you basically need to sign that message. But there is a problem here, and I will just skip a part that I explained in my previous conversation about governance, about why we aggregate the signatures. Just a short answer is just because it's easier to transport instead of having multiple signatures. We use BLS signatures just to compress or to have an easy way to manage all that signatures. But essentially, it's just like having one signature, right? So now the message is signed, but imagine again you are receiving a message: open the gates of the realm, sign Joe. Would you open the door? Is that enough proof for you? Someone says no. Okay, perfect. Well, exactly, because who is Joe, right? Is Joe this guy? Probably not. So it could be the case that you have a random Joe that has given you the message with a random signature. And you need to make sure that you know who Joe is. So you need to know which signature this chain uses in order to actually trust that Joe is the guy that is allowed to ferment this, to sign in this chain. So if you are able to do that, if you can have the concept of who is signing in which chain, or who is allowed to authorized to sign these transactions, then you can accept that. If not, you will just reject that because you know what you are expecting to get. So fortunately, we have this notion of signatures with a common signature directory, which is the P chain. And this P chain will have the node ID or the names of all the validators in the chain, as well as their signatures and the staking that they have. So with this, we already know if Joe was allowed or not to sign this signature, to sign that message. So we have, so we have this aggregation of signatures. And how this works is, because we have the P chain, the one that makes sure that every signature gets aggregated is the relayer. The relayer will take an unsigned message and will take all the signatures of the individual validators. I mean, not all of them, just a threshold that is specified in order to take that message, and aggregate the signatures and just sign the message with that aggregated signature. So with that, the flow will go like this. So that is when to take the message. Then in the other chain, when you want to deliver a message, the relayer will come and will submit a transaction, and this message will be verified that the signatures actually match what they have and in the P chain. So everything about signature verification will happen with the WAR precompile. That will be completely transparent for developers. But for you, you just the relayer will submit that message, and eventually, once the signatures have been verified, this message will be executed. So for the developer experience, it's basically like a ton of layers. Well, only 3 layers. The one is the cross-chain application that will handle all the logic of what you want to do with that message. Then we have the ICM contracts, which abstract all the complexity away from all this verification of signatures and so on. And basically, this ICM contract is an abstraction of the Avalanche Web Messaging, or ICM, which basically handles everything under the hood and just the primitives to communicate any kind of chain without it being EVM. So Teleporter, or the ICM contracts, is just the EVM implementation of that primitive layer. So again, it will go cross-chain app, ICM contract, then warp. Then the relayer takes that with the signatures, send it to the other chain. It sends the message to the teleporter contract, and it goes verifying the signatures. And then one is correct and everything looks good, it will submit that or touch the cross-chain application contracts. The one that is paying for the gas, this is important, is the one submitting the transaction in the destination chain, which in this case is the relayer. So for the developers, the only part that they touch is really the cross-chain app, which again has the logic of your application. And if you want, you can use also the ICM contracts, especially if you're working in the relayer part of things. So it gets a lot more simplified. And this is how the structure on how to send the message look like. So you have this teleporter messenger contract. That is a contract that is deployed, or you can deploy it. Actually, the next talk is going to be how to deploy your own teleporter and set everything for your own chain with Ilya. It's going to be next. But once you have everything set, you will have that contract that you can just call that send cross-chain message function. And I don't know why this keeps jumping. OK, so and these will. You need to specify which chain are you sending this to, in the sense of which town are you communicating with. Come on. I don't know why this keeps jumping. Is this? No. OK. Don't know what's going on. I know, it's crazy. So you specify the chain you want to communicate with, the contract that contains the logic that you want to execute, and then all the information feeds about how you're going to reward the relayer that is sending the message. Come on. And the required gas limit that you need the relayer to submit in order to actually pay the fee that you are rewarding. I'm just fighting with this. OK, if you specify some relayer that you want to just restrict that are allowed to send a message, you can do it there. And then, of course, the message, which is an AVI encode. I'll just go a little bit faster so we have time for the demo. And on the other side, you just need to implement this interface of teleporter receiver, where you will just, come on. It will just take the message, and it will, no, this is going crazy. I don't know what's going on with this controller. OK. So you will get the chain ID, the sender that is, you bypass that, and you have the message that you will interpret later. So about the message, it can be anything. It's just like you accept any type of message, as long as it uses like bytes for transfer the message. So as long as you encode the message to bytes, it can be whatever. You can encode as many times as you want, but the final data type that you will transfer is just bytes. And at the end, you will just need to decode. And to decode a message in bytes, you need to specify the type of data that you put in. And from there, you will be able to use that data, decode that data, and use that as, let's say, parameters in a function or whatever you want. So hacking time. Let's go. We have 5 minutes. So for you that want to follow along with this, I mean, it's going to be super quick, but anyone that wants to later do it, we have the Academy, the Avalanche Academy, where we have this Avalanche Interchain messaging course, where you will be able to find this quick example, as well as any other examples that you can follow. So let me just zoom in a little bit. This is not helping. OK, so we have the Avalanche starter kit. This is the repo. It's github.com, Avalabs, Avalanche starter kit. And you will be able to launch, if you go click here, code, you will be able to launch a code space. That is basically just a container running in GitHub Cloud. And it will come with everything you need, even some examples. The one that we are seeing right now is this just basic sender and receiver. So the sender, as I mentioned, is just interacting with this address, which is the teleporter address that is deployed we're communicating to chains in Fuji right now. So this is the contract of the teleporter contract that is deployed. And then we are just interacting with that messenger as in this send cross-chain message from this contract that is deployed there. And we're just sending like one random one message here. And that's all. We're specifying the blockchain ID we have here. Actually, I need to set this with the correct dispatch chain that we will be dispatch. As I need to go to testnet. So what we will be doing, just give me a second. Dispatch. At the end, you will find the blockchain ID, and this blockchain ID is the one that you need to set here. You're telling the teleporter contract send a message to this blockchain, and the destination contract address, we are leaving it like that because we need to first deploy the receiver, and we're sending just a regular message. Then we have the receiver, and the receiver will be deployed on dispatch, and this other chain is just like implementing. This is a contract that is a teleporter receiver. Again, it is actually just taking this teleporter contract just to verify that the message is coming from a teleporter contract. If not, this function can be called by anyone, which we don't. It's something that we don't want. And then the logic that this contract has is just storing the variable that we're sending. That was a string. We're sending that. We're decoding it here and storing that in the last message variable that we have over there. So what we need to do right now is this starter kit will come with Foundry installed. So if you, let me see, foundry.toml, this is where you list all the RPCs of the blockchains that you want to be sending messages. Right now, there is a relayer running, sending messages from C-Chain, Dispatch, and Fuji in testnet, so you can deploy these contracts without worrying anything about the relayer stuff. If you were to build your own chain, you need to make sure you have a relayer just sending the messages around. And to be super fast in this, I just have the commands. This is like forge create command, which will connect to the Fuji C chain as the RPC. It's gonna use some private key. That private key right now is I'm using the Ewok key. So if you can set your own and just make sure that you have fonts from the faucet. If not, you will need just to go to if you go actually faucet.avax.network, it will bring you to this page, and you will be able to enter a coupon code. You can use Avalanche-Academy just for that, or request any code to us. But anyway, we first need to deploy, yes, allow. We need to deploy the contract on C-Chain, and these will give you the address where it gets deployed to. Let me just copy that, and we will store that in a variable for just easy management. And then we deploy the contract on dispatch. This is the receiver contract. So we can see, yeah, this is in dispatch, receiver. I'm already on time, but I'll make sure to hurry. We save this, and then we send the actual message, which is just like an interaction with the Fuji chain, with this function, which is send message. The sender address, we set it there. And if everything went well, we can call the variable last message on dispatch and confirm that got hello. So that's it. Any questions?
So apart from C-Chain, this message can be transferred across different L1s, right?
Yeah, exactly. You don't need to go through C-Chain to communicate to L1s. You can do it, but you don't need to.
Oh, thank you.
Yeah, sure.
Any other questions? Oh, yeah.
Do you have a similar thing to send message and tokens, like in the same function?
So we have something built on top of this, which is ICTT, that will allow you to bridge tokens easily. So because it's an important piece of software that we want to have, is that already built. There's an academy course as well. You can check that in ICTT. I don't know if there's going to be a talk about that today. Is it? Yeah. Yeah, sure. That is one. So yeah, there's going to be one. Yeah, that's another quick question.
Oh,
again.
Okay, I think we have time.
Cool.
Thank you very much, Andrea, for this nice intro to ICTT. Sorry.